Hello, and welcome back to the channel and episode 6 of System Design Fundamentals, where today we're diving into API gateways. API gateway? Think of it as the front door to your microservices architecture. It's a single entry point that receives all client requests, then intelligently forwards those requests to the appropriate backend services. Instead of having your front-end applications talk directly to dozens of microservices, they only need to communicate with this one gateway. Behind the scenes, the gateway handles critical functions like routing, authentication, rate limiting, and logging. This approach is absolutely essential when you're building systems that need to scale, remain secure, and govern traffic effectively. You might be wondering, why add another component to my architecture? The answer is simplification. An API gateway centralizes all those cross-cutting concerns that would otherwise need to be implemented in every service, things like authentication, logging, and throttling requests. For your client applications, this reduces complexity dramatically. They only need to know about a single endpoint rather than keeping track of multiple service URLs. It also gives you the freedom to change your internal service structure without affecting clients. Need to version your services or implement canary releases? The gateway makes this possible. And finally, it gives you a centralized place for monitoring and alerting, making your entire system easier to manage. Let's walk through how a request actually flows through an API gateway. When a client makes a request, it first hits the gateway, which then performs several important functions. First, it checks authentication, making sure the request is coming from an authorized source. Then, it might transform the request format to match what the internal service expects. Next, it routes the request to the appropriate microservice. It might also apply rate limiting to prevent any single client from overwhelming your system, and it could cache responses to improve performance. After all this processing, it sends a clean request to the internal service, gets the response, and returns it to the client. This entire process is transparent to the end user, who just sees a simple request and response. Let's talk about the actual tools you'll encounter in production environments. Kong is a popular open-source option built on Lua, with excellent plugins for rate limiting and authentication. Netflix created Zuul, a Java-based gateway, though it's now considered somewhat legacy. If you're in the AWS ecosystem, their API gateway is fully managed and integrates beautifully with Lambda functions, IAM for authentication, and Cognito for user management. Other popular options include Traefik, Apigee, and Jinx. When choosing between these tools, you'll want to consider factors like latency requirements, the available plugin ecosystem, and how well they integrate with your existing infrastructure. Students often confuse API gateways with load balancers and reverse proxies, so let's clarify the differences. API gateways operate at the application layer, Layer 7, and excel at authentication handling, smart routing, caching, throttling, and service discovery. Load balancers typically work at the transport layer, L4, though some can operate at L7. They're great at distributing traffic, but usually don't handle authentication or advanced routing logic. Reverse proxies are somewhere in between. They can do basic routing, but typically lack the built-in features for authentication and throttling unless manually configured. The key takeaway: gateways are smarter, more flexible, and specifically designed for microservices architectures. In a microservices architecture, the API gateway plays a crucial orchestration role. It coordinates calls between services in your distributed system and enables patterns like backend for frontend, where you can create specialized gateway configurations for different client types like mobile or web. The gateway can also handle resilience patterns using tools like Resilience4j or Hystrix, implementing retries when services fail, and fallback responses when they're unavailable. Perhaps most importantly, it allows you to scale individual services independently without requiring changes to client code. In the bigger picture, your API gateway sits between the public internet and your internal service mesh, acting as the first line of defense and organization. Let's explore the essential features that make API gateways so powerful. Routing is fundamental, directing traffic to the proper service based on path or method. Authentication and authorization ensure that only valid requests proceed, using mechanisms like OAuth, API keys, or JWT tokens. Rate limiting prevents abuse and protects your services from being overwhelmed. Caching stores frequent responses close to clients for improved performance. And comprehensive monitoring and logging help you trace requests and diagnose failures. These features combine to create a robust control layer for your microservices ecosystem, giving you visibility and control over your entire API landscape. Despite their benefits, API gateways aren't appropriate for every situation. If you're building a simple monolithic application without microservices, adding a gateway is unnecessary complexity. Similarly, for internal-only systems with minimal traffic, the overhead might not be justified. For early-stage MVPs, gateways can introduce additional latency and complexity that slow down development. In these cases, a simpler reverse proxy with an authentication middleware might be a better solution. Remember, architecture is always about trade-offs. Choose the right tool for your specific context and stage of development. Let's talk about best practices that will help you succeed with API gateways. First, keep your gateway stateless. Offload any state management to dedicated stores like Redis to maintain scalability. Use API versioning to support backward compatibility as your services evolve. Implement rate limiting on a per-user or per-IP basis to prevent any single client from impacting others. Since your gateway is your single point of entry, always monitor its health carefully. Any issues here affect your entire system. For advanced internal routing, consider combining your API gateway with a service mesh like Istio, which provides additional control over service-to-service communication within your cluster. As we wrap up, remember that an API gateway serves as the control tower in your microservices world. It helps you scale, secure, and manage the complexity inherent in distributed systems. Think of it as the traffic cop standing between your users and your services, ensuring everything flows smoothly and securely. Tools like Kong and AWS API Gateway offer plug-and-play solutions that let you implement these patterns without building everything from scratch. Mastering API gateways is a critical step toward building production-grade architectures that can evolve and scale with your business needs. Thank you for watching this episode about API gateways. In the next one, we will have a look at something interesting: design Instagram, scale for billions. Stay tuned for the upcoming episode. Before you go, I'd love to hear from you in the comments. If you found this video helpful, do give it a like, share it with your friends, and of course don't forget to subscribe to the channel to help us grow. I will see you in the next one. Till then, happy learning.